everyone, we're going to start taking a look at chapter 4, which talks about triangles. So we are going to start with talking about classifying triangles. So we've got 4 types of triangle classifications by angles. So classifying by angles: an acute triangle, which has 3 acute angles; obtuse triangle, which is a triangle that has 1 obtuse angle; right triangle, triangle with 1 right angle; and if a triangle has 3 congruent angles, it is an equiangular triangle. So you can take a look here and review triangle CDE. You name a triangle by calling its 3 vertices. Triangle CDE is a right triangle, and so on and so forth. So take a moment to pause the video and double check the classifications of these 5 triangles. We can also classify a triangle by its sides, by its side measures. So again, triangles are closed shapes with 3 sides that also result in 3 angles. And we classify triangles by angles and by sides. So to classify by sides, we can call them equilateral if they have 3 congruent sides, isosceles if they have 2 congruent sides, and scalene if they have no congruent sides. And we use the hash marks to indicate congruency. So again, 6, 7, and 8, you've got 3 triangles classified by their sides. So for example, JKM, triangle JKM, looks like it's scalene because this side is not congruent to this side, who's not congruent to that side. We also classify or name triangles, we name triangles by classifying it by its angles and its sides. So this would be a right isosceles triangle because it is a classification by angle, which is a right triangle, and by side, which is isosceles because it has 2 equal sides. Your obtuse is scalene, and equiangular, equilateral. So 3 congruent angles and 3 congruent sides. Okay, on this next page, I would like you to go ahead and name triangles 12, 13, and 14 by angles and by sides. And then try classifying 15, 16, 17, 18, 19, and 20. You've got a whole mess of triangles up in there. Go ahead and try classifying those triangles by angles and by sides, but please take note here. It says PR bisects SRT. So PR bisects SRT, angle SRT, so it bisects it. So that's important, what happens here. And U is the midpoint of RT. Okay, that's important, so what happens here. And once you kind of mark up this information that you were just given and what you're able to conclude, go ahead and see if you can classify these triangles by angles and sides. Pause the video and do it now, and then play the video to check your answers. All right, so here are the answers to 12 through 20 with the classifications. Do you have questions about any of these? If so, make note of it. If you can't figure it out after seeing the answer, make note of it so that you can ask in class. Again, if you cannot figure out how this answer came to be on your own, please ask in class. All right, moving right along. So we've got a triangle, JKL, and we need to classify it by its sides. But in order to do that, they gave us the endpoints of the triangle as coordinate pairs, and we want to classify it by its sides. So in order to be able to classify by its sides, we actually have to find the measure of each side. And lucky for us, we can find the distance between 2 points by using the distance formula, which distance is equal to the square root of x2 minus x1 squared, y2 minus y1 squared. What is the distance going to give us? Well, let's say this is what triangle JKL looks like, which unless we graph it on a coordinate grid, we won't know. Oh, JKL, sorry. The distance between points J and K will actually give us the measurement of that side. And the distance between points K and L will give us the measurement of this side, and the distance between J and L will give us the measurement of that side. And then once we know the measurements, then we can determine, is this isosceles, is it scalene, or is it equilateral? So let's find the distance. Oh, let me move this out of the way. Here we go. Okay, sorry about that. Let's find the distance for segment JK. So do this distance formula, and you get the square root of 68. Actually, just stop right there. Let's find the distance between point K and point L. To find that that segment's measure is also square root of 68. Remember the distance formula? x2 minus x1 squared plus y2 minus y1 squared. Remember, it's the square root of the Pythagorean theorem. We talked about that a while back. I showed it to you. And let's find the distance between, we did JK, we did KL, and then the third side of the triangle is JL. I don't know if this is what this triangle looks like, but let's just draw a pretend one. So we're missing JL, and JL is square root of 72. So it looks like this triangle has two congruent sides, so it is isosceles. So here are the answers. Pick one to try on your own without looking at the answers and see if you get the same thing. And let's move on. So actually, this is a really great place for us to take a quick pause. And this is where I'd like you to try on your own. Now that you know how to name triangles by angle and by sides, and you know what all of that means, see if you can make the connection to do a question like, if triangle ABC is an equilateral, solve for x and y. Well, if you know it's an equilateral, that means that all sides are equal. So that gives you a statement of equality. And if it gives you a statement of equality, you can set things equal to each other to find both x and y. So this is where I want you to go ahead and do these 5 questions. And we'll start class, when we meet again, we'll start class with checking the answers to these 5 questions and moving on. Thanks for watching.